Greetings and welcome to the introduction to astronomy. One of the things that I like to do in each of my introductory astronomy classes is to begin the class with the astronomy picture of the day from the NASA website, that is apod.nasa.gov/apod. And today's picture for March 3rd of 2023. Well, it is titled RCW 86 Historical Supernova Remnant. So what do we see here? Well, the little bits of material scattered around the edge of the image are the remnants of a star that was seen to explode nearly 2,000 years ago. And it was at this position, or at the central position of this star was recorded by Chinese astronomers in the year 185. So close to 2,000 years ago, a new bright star appeared in this portion of the sky. And that is an example of a supernova. And here we're seeing the remnant material from that star that was expelled out into space. Now, this is an example of the remnant of a type 1 supernova. And one of the ways we can tell that is that detailed studies show no sign of either a neutron star or a pulsar within this remnant. They would be left behind if this was what we'd call a type 2 supernova. A type 2 supernova is a massive star at the end of its life that becomes unstable and explodes. A type 1a supernova is a star that has already died, a star like our sun that collapsed down to a white dwarf star. Now, a white dwarf star has a limiting mass. It has a certain amount of material that it can hold before it collapses under its own weight. Much as if you take a rickety old table and start piling heavy books on it, eventually you'll put one book too many on it and it will collapse. Well, if a star gets a little bit too much material on it, it will then collapse, and that will ignite thermonuclear reactions within the entire star, tearing it apart and expelling the entire star off into space, leaving nothing behind. So that's why we see nothing towards the central portion of this, nothing left behind, just the material out at the edges that has been expanding outward into space now for nearly 2,000 years. Studies of that material show that it is heavily enriched in iron. Iron produced in very massive stars is the end point of nuclear fusion reactions, because once you get any higher than iron in terms of the mass, you cannot gain any energy by fusing elements together. It will start to take energy to complete that. So we see a lot of that when we look at the outskirts here, when we take a spectrum of it and study the composition of that material, we find out that iron is very prominent within this material as well. So a supernova itself lasts a relatively short period of time, that the star would be incredibly bright, and then the remnant will expand out into space. But here we can see that even after just a couple of thousand years, it is fading out into the depths of space and becoming seed material for new stars. So things like this are where a lot of iron and other heavier elements on Earth have come from explosions of massive stars. In these cases, many billions of years ago, that eventually became some of the material that helped form our sun and our solar system. So that was our picture of the day for March 3rd of 2023. It was titled RCW 86 Historical Supernova Remnant. We'll be back again tomorrow for the next picture, previewed to be 10 days of Venus and Jupiter. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.